Yahoo! Coming back. Welcome back. Let's move on to question 11 now. Alright, question 11. The arc of a concrete bridge has the shape of a parabola. Alright, so this is the concrete bridge. Parabola. It is 6 meters high and 8 meters long. So 6 meters high and 8 meters long. Alright. Find question A. Find the rule for the function corresponding to the arc of the bridge. So we have to find a function represent this. Alright. So we know it is a parabola, and if we write out the standard form of parabola is y equal to ax squared plus bx plus c. So we have three variables, a, b, c. Right? So we need three things to solve those three variables. So look at here, we've got one point here. That point is 4, 0, I believe. We've got another point here, which is -4, 0, and the last point is here on the function, which is 0, 6. So that's 3 points, and that's more than enough to help us find the function for the bridge. All right, let's start. So let's work with the y-intercept. Let's work with the y-intercept first. So when y is equal to 6, x is equal to 0. So a0 squared plus b multiplied by 0 plus c. Obviously, 6 will be our c. All right. After that, we plug the rest, the other 2 points into the function. So let's plot the -4 one first. So 0 equal to a multiplied by -4 squared plus b multiplied by -4 plus c, which is 6. So 0 equal to 4 squared, and -4 squared is 16, 16a. B times -4 is this -4b plus 6. Alright, so that's 1. And the other point is 0 equal to a 4 squared plus b multiplied by 4 plus 6. And that would be 16a squared plus 4b plus 6. Alright, so we got two equations. Equation 1, equation 2. And we can use simultaneous. We can solve these two simultaneously. It's 2 equations, 2 unknown. Alright, so let's use the look. I know I said I love substitution, but I mean this is obvious. We should use elimination here because most of the constants are pretty much the same. So let's use that. All right. So the function 1 is 16a minus 4b plus 6, and the other function is 16a plus 4b plus 6. All right, let's plus these two functions. So 16a plus 16a will be 32a, and minus 4b plus 4b just cancel it out. So they're both equal to 0. Yep. Plus 6, positive 6 plus 6 is 12, and 0 plus 0 is 0. All right, let's move the 12 to the other side. So 32a is equal to -12. Right? And a will equal to -12 on 32. Right? And I think we can simplify that, taking the common factor 4 out. So it'll be -3 over 8. Yeah, that would be our a. Now we can sub a back into any of the function. Alright, they should both work to find out b. Let's just do that. So let's just choose this one. Right? So 16a plus 4b plus 6 equal to 0. So we sub that in. We sub the value of a into here. So it will be 16 multiplied by -3 over 8 plus 4b plus 6 equals 0. So 16 multiplied by -3 would be 48 over 8. It's a negative there. Plus 4b plus 6 equals 0. Now 48 divided by 8, I think that is just 6. If I remember right. Yep, it is. Timetable, woohoo! So that's negative 6 plus 4b plus 6 equal to 0. Now negative 6 plus 6 cancel out as 4b equal to 0. Therefore, b is equal to 0. Alright, so right now we should get we should have all three unknown ready, and therefore our function is therefore the function for the arc of the bridge is y equal to negative 3 over 8 x squared, no b, and plus 6. Alright, let's just go to decimals and plot that and see if it is the right one. Boom, we're back. So I got the graph from decimals and it looks exactly like the one that's given in the questions. So we've got the intercept, y-intercept at 0, 6, and 2 x-intercept at negative 4, 0, and 4, 0. Alright, so it looks like we've got the right equation. Let's do the second question. Find the area of the shaded region. Alright, the shaded region is all there. Okay, so it's just here, the shaded region. Okay, so it's obviously we have to use integration, right? Because it's finding the area under two curve. Alright, the first curve is, remember, we always have to we also have to be able to see the top curve. The top one is this one, and the bottom one is this one, right? This is bottom, and this is top. Now the function for the top one, since it's a straight line, and that would just be y equal to 7, right? So to find the area between the two curves, we integrate top minus bottom, right? And with respect to x, that is. All right. There's a little trap here that I hope you guys can see. I will actually draw I'll draw the bridge over here. So it was like it's 5, right? So 5's in the middle. So it's like this. And 6 should be in the middle as well. 7 should be in the middle as well. So it's like this. Wonderful straight line I got. And then here. Okay, so that's what that's what it looks like. This is y equals 7. Remember, y equals 7. So, but here, if you would go, oh, so this is negative 5, this is positive 5. So if you go, oh, I'll just integrate the two. I'll just find the integrate and find the area between the curve, between the two curves, from negative 5 to positive 5. If you do that, if you actually just do that, you will actually find all these areas, right? Because you keep going down. You will find all these areas. But you realize now, by now you will realize, hey, I don't need this bit. No need. I don't need this bit. I don't want this bit. I don't want this bit. But if you just integrate like that from negative 5 to positive 5, you will get those one, which makes your answer incorrect because you will have more area than what you're supposed to do. So this is the little trap that they have in here. So what I would do is I would calculate, all right? I would calculate this little rectangle area first, right? This little rectangle area, same as here, right? So because the width of this is 1, right? From negative 4 to negative 5 is 1, and the height of this, the length of this is 7, from 0 to 7. So right, so we could know the area of the rectangle is equal to length times width. Is also equal to 7 times 1 equal 7 meter square. So I know this is 7 meters square. And same as here, so same will be here, 7 meters square. So I can get that and then integrate the area between the two functions from -4 to 4, which wouldn't give me any of this extra area down there, because that's where this 2 point is. That's why we integrate from -4 to 4. All right, so this is a little trap. They got it here. All right, so let's just put down our domain from -4 to 4. All right, then let's integrate it. So remember, it's top minus bottom. The top function is y equal to 7, so we just put 7 down. And the bottom function is, as I remember, should be negative 3 over 8 x squared plus 6, right? And then integrate with respect to x. And then we can expand the brackets by distributing the negative in there. So it becomes negative, negative becomes positive. And negative, positive becomes negative. Right? And then, oh, that's a little bit here. And then we can fix the 7 and the 6, right? Because 7 minus 6 is just 1. Plus is 3 over 8 x. Oh, there's not x cubed, x squared. This is x squared here. Yep, got x squared. I don't know why did I write x cubed. X squared division x. Okay, and then let's do them individually. So integrate 1 with respect to x, plus is integrating 3 over 8 squared with respect to x. All right. So we know we get when you integrate 1 with respect to x, when you integrate a constant with respect to a variable, you just get the constant times the variable. So it's just x, right? 1 times x is just x. Pluses. So we can take the constant out first. We can take this bit out. So it's 3 over 8, integrating x squared with respect to x. Right. So put the domain there. So it's equal to x plus 3 over 8 multiplied by, so the to integrate x squared is the power increased by 1 divided by the new power. Right? And there's no c. Remember, this is definite integral. Yep. So then we get 8 pluses. So we just simply multiply these two. So it's just 3x cubed over 8 times 3 is 24. From -4 to 4. All right, we can just sub those two values in and minus each other. So it's equal to 4 pluses 3 times 4 to the power of 3 over 24 minus -4 plus 3 times -4 to the power of 3 over 24. Okie dokie. So 4 plus, now 3 times 4 to the power of 3 divided by 24. Let's use the calculator. 4 cubed times 3 divided by 24 give us 8. Minus -4 plus. Now this would literally give you the same thing, which would be 8. But the -4 cubed is not a positive number. It remains a negative number. So instead of positive, it's actually -8 here. So this is 12 equal to, now -4 plus -8 is the same as -4 minus 8, because gives you -12, right? And this will give you 12 minus -12 is 12 plus 12, which is 24 meter square. Remember, we're finding the areas, right? Meter square. All right. So therefore, the total area. Remember those two rectangles, we have to plus them now. The total area equal 24 pluses 7 times 2, because it's 2 rectangle, one on the left, one on the right, right? So that's 24 plus 14, which gives you 38 meter square. All right, so that's the answer. So therefore, what's the question again? Find the area of the shaded region. Okay. Therefore, the total area of the shaded region is 38 meters squared. That's it. Perfect. Loving it. Okie dokie. Let's go to the last question. Last question is, if the bridge is 10 meters wide, find the volume of the concrete of the bridge. Oh, I just draw it here. So if the bridge is 10, so this means, and that means that bit is 10. So just a new dimension added on it, right? So all we have to do, volume is equal to area times another dimension. So therefore, volume is equal to 38 times 10. So it's equal to 380 meters cube. Yeah, so that's the volumes unit. So we can answer the question. That's that easy. This is exactly that simple. So if you're going to, find the volume of the concrete in the bridge. So therefore, the volume of concrete in the bridge is 380 meter cube. Yeah, and that's the answer for the last question. Whew. All right, that's question 11 done. Okie dokie. So let's go into a commercial break, and we come back to with question 12.